let's say that we've got a sensor with the following range. Let's say that the uh, range of the sensor is 2.5 volts to, doesn't matter what the sensor is, let's just say it's some sort of vibration sensor. How about that? This is the range of the sensor. And let's say that the range of our analog to digital converter, the thing that's going to be measuring it, range of the ADC, let's say that it's 0 to 5 volts. This is a pretty common thing for something like an Arduino, right? 0 to 5 volts, a lot of microcontrollers. So what we kind of have is, if this is the range of our ADC, right, if this is the range of our ADC, the range of our sensor is kind of right here, right? This is 2.5 to 5 volts. And so let's just do sensor here and ADC here. So we're actually not using the full range of our ADC, which means that we're not getting the max resolution that we could be getting out of it, right? We're not utilizing it to its full potential. So the first thing we want to do, I actually put this kind of in the opposite order that we do things, is normally what you want to do is offset this signal if you want to start using this full range. So to offset this signal, kind of what you want to do is offset by the bottom part of your range, right? You want to offset by 2.5 volts. Right? In this case, you want to offset by the bottom of your range. So essentially what we're doing is we're taking this guy and subtracting 2.5 volts from it. So we're gonna, just for this step, we're gonna say offset by negative 2.5 volts, right? We want to subtract 2.5 volts from it. And now we can't really do anything else with an offset, right? Because we're where we need to be. But now what we need to do is multiply this signal, right? We need to multiply this signal. And so to figure out what we want to do there, right, what we can do is we can just take our ADC range, or how about this? We will take what I want to say, the max new sense range. So the maximum of the new sensor range, meaning after the offset, what is the maximum? The maximum here is now 2.5 volts. So we're going to say, just kind of a little arrow here, 2.5 volts. So we've got that, and we're going to have that divided by the ADC max. Or that's going to divide the ADC max. We've got 5 volts. So what do you end up with here? Well, we end up with 2. So, and we could kind of see that, right? If we doubled this signal, we would get that full range, right? So after we offset it, right, so this is the offset step, and then a gain of 2, or a multiplier of 2, or an amplification factor of 2, will cause this to happen. Right, we offset it, and then we amplify it, All right, so this is our ADC range. This is our sensor. So we're using the full range here. So we offset by 2.5 volts. And then here we get our gain by taking the ADC max and divide it by the sensor range to get what our gain should be. So here, let me just put a quick note here. This is our sense minimum. So just for there could be a case where this sensor minimum is actually negative, right? It's 2.5 or negative. Let's say it's -1, then your offset would be +1, right? You want to add 1 volt to get it to your minimum range there. Usually your range is always going to be 0 to 5 or 0 to 3 volts, right? It's going to start at 0. You're not really going to have negative for the ADC. So yeah, so these are your two big values here, right? We've got this guy. Oops. Not so good with the drawing. Got that guy and that guy. Let's look at what this kind of looks like in a simplified schematic, right? So simplified schematic, we're going to have our sensor N, so this is our sense. And this isn't a very common notation. This is something I kind of do. I like to write my range here. So my range coming in is 2.5, 5, right? My min and my max. And that goes into this thing called a summing junction. So this means we're adding this value and we're adding this value. Sometimes you can see the sign as a minus, but for this case, I just do everything as plus. So we have an offset of 2.5 volts, right? Here's our offset. All right. And now what we do is we amplify it. So this is a gain, right? Or some sort of multiplier. And, let's put our range here, right? Our new range is 0 to 2.5. And then here we're going to have a gain of 2. So, you can put the gain right in there. You're multiplying it. And so then we know 0 times 2 is 0. And 2.5 times 2 is 5. Right, so this is to our ADC now. Yeah, so that's kind of the very basic way to look at this kind of problem. And these circuits, if you actually wanted to build them, they would be made out of these devices called operational amplifiers. Or, there's some other specialized circuits that you can use for that. But usually I would do this with an op amp. And just real quick, this is our